Okay, so the last one here is a 400-meter track. Okay, we have two straight lines and two semicircles at the ends. And the straight sections must be at least 100 meters long. And the radius of circles must be at least 20 meters. And we want the max and min areas. Okay, so if we want the max and min areas here, we first of all, okay, so let's move over here, some clear space. This is number 3. Okay, we need a diagram for this. So the diagram is going to look like this. We're going to have lengths, which I'm going to call x. Okay, then the semicircles, and those semicircles are going to be based on 2r. Okay, 2 times the radius. And too many variables there, so we need to connect those variables together. We're going to do that in this way. So we know that the whole perimeter is 400, which is 2 straight lengths plus the circle. Okay, half a circle, plus 1 full circle. Okay, so I'm just going to do this in red. So that length here and that length here make up 1 full circle, so 2 pi r. Okay, so that's one thing. We want to relate those lengths, and we want to then come up with an equation for area. We need to minimize the area. So area is equal to the 2 circles. So I'm going to write this as pi r squared. So sorry, 2 half circles, which is 1 full circle. And then we're going to have the rectangle. That's going to be this area in here. Okay, that area is going to be plus 2r times length of x. Okay, so that's the equation I want to minimize. I've got too many variables here, so the easiest way to get rid of it is we need to, we can just solve for that x and replace that x. Okay, so I'm just going to go ahead and do that. Area is equal to pi r. Well, let's do this first. So we're going to say 2x equals 400 minus 2 pi r. So 1x is equal to 200 minus pi r. Okay, so I'm going to replace this expression. So this x gets replaced by that. So my new expression for my area is going to be pi r squared plus 2r times 200 minus pi r. Okay, so we can now go ahead and differentiate this, but this problem had some constraints on it, and the constraints were, oops, where is that now? The constraints were the track must be at least 100 meters, and the circles, the radiuses must be at least 20 meters. Okay, so the maximum, we're going to do this in terms of radius, so we want to know the max and min of the radius. So we know that the radius, I'm just going to write it here, the radius must be between 20 and some value that is going to make sure we have at least 100. Okay, so the shorter that is, the bigger the arcs are going to be. So I want to know what my radius is going to be when x is at least 100. Okay, so I'm going to do this in a different color. I'm going to use this equation. I'm just going to let x equal, I'm going to do a let here, just do off to the side, let x equal 100 and this is to find the absolute maximum of r, right? That's the smallest x can be, so that's going to give us the maximum of r. So that'll give us some parameters to work with. So when I solve this, I'm going to get pi r equals 100. R is going to be 100 over pi. And that's approximately equal to, let's see here, 100 divided by pi is going to be about 31.8. 31.8. Okay, so we know that the radius is constrained between those values. Okay, 100 over pi, and again, like I said, that's approximately 31.8 meters. Okay, so now that I've done that, I'm going to differentiate this, and a prime, oops, I should let's simplify this first before we differentiate. So we're going to end up with 400r, and then we get negative 2 pi r squared, so we're going to get negative 1 pi r squared. Okay, differentiating this, I get 400 minus 2 pi r. To find the min or max point, I need to solve for that equal to 0. So I get r is equal to 200 over pi. Okay, so that's approximately 62 point, whatever that is, 62.6, somewhere around there. Okay, so now what? The problem here is if I let that be 62.6, that means that I've gone beyond my radius here, and those lengths aren't long enough. Okay, so I've gone beyond my bounds here. So I have a situation where my min or max, I don't even know if that's a min or max, is outside of this bounds. And I also know that since that's a max point or a min point, it's either strictly increasing in there or strictly decreasing in there, which means that one is a max and the other the min, or vice versa. Okay, so I'm just going to draw a chart here. Here's my domain 20 and pi 100 pi, and basically all I need to know, and then 200 pi's, I'm just going to stretch it out here. 200 pi is way out here somewhere. 200 over pi. Okay, somewhere over there. Okay, so I know that there's a 0 here. Okay, now it's either increasing like that or it's decreasing like this. That's what I know. Okay, that means that in this region that I'm looking at, it's either increasing or decreasing. So I'm just going to test one point. Okay, so I'm just going to test A prime at, well, convenient number, let's choose 25. Okay, or 30, that might be even easier. So A prime at 30 is going to be 2 times pi times 30. Okay, so 2 times pi times 30. 2 times pi times 30 is going to be 180. So I know it's going to be increasing like that. Okay, so just make sure I got that right. My radius is 25. It's going to be 50 pi. Yeah, it's going to be positive. So I know it's increasing. It's going to go like that. Well, that means then that this, if it's strictly increasing, there's my min value. Okay, that's my min at x equals, or r equals 20, and that must be my max at r equals 100 over pi. Okay, and then I don't know if the question asks for the actual area, but if you want to do the max min area and min area, you just plug it back in. We find our radius, and you can calculate x from that. And where's our x here? Our x, we can just plug it back into that equation. Okay, so let's just finish this off. So x, this is our min, is going to be 200 minus pi times 20, so 20 pi. Okay, whatever that is. And our max is going to be 200 minus pi times 100 over pi. So it's going to be minus 100. So the maximum is going to be when x is 100. Well, we should have known that because that was what we calculated here. Okay, so x max and x min.